Hi everyone, welcome to this video on generics in C#. So I have created a console application and I've created this class generics demo and I'm having a client main method in here. So this is more or less a replacement to this main method that we have in our application, and this effectively essentially is going to call this client main of the generics demo. And why we have done it like this is because we are going to have other demos in the same project as well. So I don't want to clutter this main method itself. Whichever demo we will be going through, we will invoke that particular demo's client main method. So for now, we're going to invoke generics demo.client main. And here we are going to do all the stuff regarding generics. So starting with a little bit of theory about generics, Microsoft documentation says that generics introduces the concept of type parameters in .NET, which makes it possible to design classes and methods that differ the specification of one or more types until the class or the method is declared and instantiated by client code. What this means is that we no longer have the need to create our classes and methods strictly coupled with a particular type. For example, let's say that we are writing a method which adds up to integers. So that method needs to know during the compile time itself that I am supposed to work on instances of ints and I'm going to add them. But generics gives us the flexibility to create methods or classes which just are coupled to a placeholder type and not to an actual type, and that placeholder is not known at compile time. That will be provided with actual implementation, actual type whenever we are trying to invoke that method. We will have a look at how to implement that in code in just a bit. Let's go through the second point first, which says that there are three main benefits of using generics, that is reusability, type safety and efficiency. Reusability, because without generics, if we wanted to add strings and integers, we would have to write two separate methods, one add strings and another add integers. And in future, if we feel the need to add more types, for example adding employees, that could be a requirement. So in that case we would have to write another method for each type. But if we are using generics, then we can simply write one method, that is add t being the type parameter, and it is going to be a placeholder type. So whenever we want to add integers, we would pass int in place of the type parameter t and supply integers to that method, and that would give us a result back in integer format. And similarly, we can use that same method by passing employees in place of t, and that would add employees. And we can of course override the add method in the employee class, whichever way we want to. And the next thing is that we can have these things, these entities of C# as generics, which are interfaces, classes, methods, events, structs and delegates. In this video we will mainly focus on classes and maybe a little bit about methods as well. But for the remaining topics, that is interfaces, events, structs and delegates, we will have a separate video. Structs I don't think would differ much from classes in terms of their generic behavior, so we might not need to discuss them in detail. But for interfaces and delegates, we will definitely have to create another video because they also support covariance and contravariance, which is not there in classes. So that's a whole another concept which we will tackle once we reach there. Now coming to the next point, which is regarding constraints on type parameters. So before coming to this, let's have just a little bit look at how to write generic classes. So after this class, I'm going to create my new class. Let's call it a basket. Now without generics, I would have to write something like fruit basket, not fruit basket, let's say orange basket, and apple basket. So I would have to create a separate class for each fruit that we have, and that is not so good. So with generics we can create a single class, let's call it basket, which will have a type parameter t. We're just denoting it with t. It can be anything, it can be fruit as well, okay, but let's go with t right now, and that's it. So that's our generic class being defined here. Let's format the code a little bit. Okay, now we will create some classes which can go in place of t. So I want to create public class apple and public class orange, and I'm going to inherit both these classes from fruit class, which I'm going to create now. I think I have the code copied for fruit class. Okay, so we have three simple properties, that is color, price per kg and price per dozen in the fruit class, and apple and orange classes are fruits, so they are inheriting from this fruit class. So what this means is that, okay, I don't think we need this, we don't need to discuss this thing right now, but let's keep it here. Okay, for now let's keep it here. We'll see if we need to comment that out or not, because that involves a little bit of variance, and I'm planning to discuss variance in separate video. So coming to the main method, now we have to instantiate the basket class. Whenever we are instantiating a class, we need to supply all the type parameters that this class is dependent on. For now we have created only one type parameter, but we can have any number of type parameters, and we can denote it with anything. We can denote it with ABC1, anything we want. So now let's stick with only one type parameter, that is t, and here we need to supply we need to fill this placeholder type, and let's call it basket of apple. Let's name the variable apple basket is equal to new basket of apple. Similarly, we can create a basket of orange. So this is how we instantiate generic classes, and we don't have any constraints as of now on t. So what this means is that I can create a basket of anything, basket of int, let's call it b1 is equal to new basket of int, and int is a struct, orange is a class, and we can pass anything right now. But now let's come to the constraints, and the first constraint is that we call these primary constraints, which represents that what exactly is the type of entity that we are passing. Is it a class or a struct? So let's first put a constraint here where t colon, and after colon we can have multiple constraints comma separated. So let's place class here. Now what it means is that this entity that we are passing here, type, that has to be a class. Apple and orange both are classes, so that is fine. Int is a struct, so that's not fine. And if we mark it as struct, then int will be fine because int is a struct, and apple and oranges will throw error because they are not structs. Let's stick with class for now, and let's get rid of this basket of ints. Now let's come to the second constraint, which is new. But before that, let's do something like this. Instead of class, we can give our own interface or class here. If I write fruit, what this means is that anything that we are passing here has to be of type fruit, and by this I mean that somewhere in the chain of inheritance, this class that we are passing here should be deriving from fruit. Maybe not directly, but somewhere in the chain of inheritance, fruit has to appear above apple. And to demonstrate that this will throw error, if we comment this out, now apple is not inheriting from fruit, so in this case we will get an error here. So this was the second constraint, and now the third constraint is new. What this enforces is that the type that we are passing must have a public parameterless constructor. And why we may need this kind of response is that suppose there is something like add a random fruit to the basket, and in that case we might have to instantiate an object of this type. So if we have not enforced that the type that we are passing must have a public parameterless constructor, there is a possibility that there is no parameterless constructor, or there is a private constructor. So in that case we won't be able to instantiate an object from here, and that is going to throw an error. So let me demonstrate it right now. And why apple and oranges are fitting into this constraint right now is because they have a default parameterless constructor. Every class in C# has a default parameterless constructor. So let's say that we have a method in here. And here we are instantiating t. New fruit is equal to new t. Okay, will this work now? Yes, because we have made sure by this constraint that t must have a parameterless constructor. But if we get rid of this, then we'll see an error. New expression can what it says is that cannot create an instance of the variable type t because it does not have a new constraint. So that is how the new constraint works. Now once we have instantiated this t class, we can access the properties present in the fruit class: color, price per kg, and price per dozen, because we have added this constraint that t has to be of type fruit. So we can see all these properties in IntelliSense, that is price per kg, price per dozen, and color. We can set something like this. So that covers the new constraint as well. We've also had a look at this one where we can specify our class or our interface. Now there is one more constraint. Okay, so just in case that if we have multiple type parameters, let's say p, and I'm going to comment these lines right now because, okay, let's not comment them, let's rectify this instantiation after defining the type. So here, if we want to add constraints to the second type parameter, we can write where again p, and now the constraints of p will be written here, comma separated. So we can say something like this. What this means is that the second type parameter has to directly or indirectly inherit from the first type parameter. Let's comment one of these, and let's pass green apple here, and let's create a green apple class. So currently this green apple class is not inheriting from the apple class, so we will get an error that if we have a look at the error message, it says that cannot be used as type parameter p in the generic type of method basket of t comma p. There is no implicit reference conversion from green apple to apple. To rectify this, if we make this class inherit from apple, now it would work, right? Because we have put this constraint, p must be deriving from t. So this wraps up our this constraint as well. Now coming to this point, which is talking about unbound type parameters. So by unbound, we basically mean that a parameter, a type parameter which does not have any constraint specified. So something like this. Now t is not unbound because we have specified some constraints over t, but p is unbound. And what problem we will face with this is that suppose we have a method here, let's call it m1 for now, and let's say that it is receiving some instances of t, t1, t, t2. So 2 objects of type t and 2 of type p. Now if we say where equal is equal to t1 double is equal to t2, will this work? Yes. Why? Because we have made sure that t is a class by specifying this constraint, because fruit is itself a class, and every class in C# can be compared using the double equal to operator, which basically checks the reference equality of them. But if we have not specified any constraint over p, and if we try to compare the objects of p, we will get an error. And if we look at the error message, it says that operator double equal to cannot be applied to operands of type p and p. And why are we getting this error is that if we talk about structs, they cannot be compared by using the double equal to operator. We need to make an override for double equal to operator for our structs in order to get this working. And since that we've not specified any constraint over p here, it means that we can pass an instance of the struct here. So that is why this thing is not allowed. And same is the case for not equal to. So it gives a compile time error so that we don't encounter a runtime error. And now coming to the next point, instantiating generic classes. So we've seen how to instantiate generic classes already, but let's look at something else. So let's say that we have one generic class. Let's call it A, and it is dependent on only one type parameter t. And now let's have another class B. It is dependent on, let's say, 2 type parameters p and q, and it is also inheriting from A. Okay, so whenever we are instantiating a class, all the type parameters should be specified, and whenever we are inheriting one generic class from another, we should specify all the type parameters, or we should actually fill all the type parameters of the class from which our class is inheriting. So in this case, the complaint is that A is not receiving any type corresponding to the type variable type parameter t. So what we can do here is we can write q here, and this q will be coming from this. So whenever, let's come to the main method again. So whenever we create an instance of b, let's say int string b is equal to new b, in this case the second type parameter, that is string, which is represented by q here, will be passed to a. So the a's placeholder now will be substituted with string, because we have specified the second type parameter as string. So that was about instantiating generic classes, and also a little bit about inheritance in generic classes. So that is all that we're going to cover in this video. I hope you learned something from it, and if you did, please like, share and subscribe. Thank you.